Hey everyone, welcome to this Azure is 100% high available, or is it? Presented by myself, Peter D. Tender, and this session is part of the one and only Azure Back to School, where I want to thank Dwayne Netwick to actually organize this for the second year in a row. And what we're trying to do out of Azure Back to School is giving you a lot of Azure related content over the course of 1 month. Given it's the second year we're doing this, you can still go back and watch all the amazing content from last year. I know it's 1 year old and Azure is going a lot faster than that, but it should still give you a lot of really interesting content. Now, thinking a couple of steps before cloud, I would say, think back about your on-prem environment, where you're going to deploy server, storage, networking, running your workloads. And before you could actually run your workloads, or even while the workloads were running, you needed to come up and answer a lot of those questions. Well, now you're going to move to a cloud scenario, and that's where we talk about infrastructure as a service. You still have a couple of questions that you need to get answered by yourself or your architecting teams, but it should be a little bit easier than running everything still on-prem. If you don't like virtual machines anymore, or maybe even better, you don't want to worry that much about answering all those questions, you would slightly move into platform as a service, and eventually you would end up with serverless, where you just have one single question. Please, this is my workload, and can you run it for me? And you don't have to worry about anything that's running as a platform, running as an infrastructure, and we're gonna manage all that for you. In short, the main message: bring your workloads to the cloud. Reason number one, it's cost efficient. Reason number two, it's more secure. And reason number three, it is 100% high available. You know what? I even tweeted about this a couple of times already. That's how much I believe in those keywords. Way cool. Did you enjoy the marketing bit? Awesome. That's my session. Thank you so much, and see you again next year for another back to school event. Obviously, it's not that easy. This is just getting you into my session, I would say, where this is going to be a little bit more formal. Thank you once more for being in my session. My name is Peter D. Tender, based out of Belgium, and working as a Microsoft technical trainer or an Azure technical trainer, but our official title is a bit broader than that, since we provide Azure technical training or security courses or Dynamics, but that's not in my portfolio, to Microsoft customers and partners all over the world. Been working as a overall Microsoft trainer, consultant, architect for customers in Europe and all over the world before I joined Microsoft, literally 2 years and a bit ago, and joining the trainer team, but still pretty heavily involved in community work by writing a couple of Azure focus books and presenting sessions like this one. So the main scenario is Azure 100% high available. The good news is it's not, because otherwise that's where my session would end, right? What's more important is that I'm going to walk you through the next 30-40 minutes, sharing a little bit more insights on how you can max out the high availability when you're architecting Azure solutions. Now, before diving into Azure specifics, let's spend a couple of seconds on what do we mean by high availability. Overall, out of the industry, we always talk about SLAs. If you want to drill down, we talk about numbers of nines. 3 nines, 4 nines, 5 nines. That's a typical industry expression to illustrate service level agreements. In Azure, we only talk about monthly SLAs. Although technically it might be downtime per hour, per week, per day, per quarter, but the one and only official statement is monthly SLAs. On the other side, what is an SLA? A service level agreement. It's actually nothing more than a financial compensation if the uptime of our service, of the platform, of your Azure resources is less than what we commit to. So don't get confused with other, I would say, more technical, more real uptime metrics. Like you have SLO, service level objectives, SLI, service level indicators, or even more specific technical metrics, mean time to failure, mean time between failure, mean time to repair, those kind of metrics. So financial, and it should actually give you a pretty good estimate. From here, I'm going to make it a lot more technical and using a bottom-up approach. Starting from Azure Datacenters, we have a couple of different ones all over the world. And what is the high availability, and what is more important for you as a potential Azure customer, Azure consumer, maybe cloud solution architect, to know about. So I'm going to start from the data center, slightly moving up to your actual running workloads. If you think back about my marketing pitch, starting from IaaS, moving to PaaS, moving to serverless, and in between, not to make it too PowerPoint oriented, shifting with a couple of demos as well. So let's jump in the data center scenario. Azure for now has 64 active regions all over the world. It means that no matter where you are in the world, you could probably find a close by Azure region where the Azure region is giving you functionality. 64 active ones and at least another 25 on the roadmap. If you have an Azure region that's a little bit too further out, I would say check back that infrastructure map website. I'll show you that in a second, where you're going to find a lot more details about what is running in each and every region, what is the region high availability, what are all the services, together with SLAs for the services in the different regions. Apart from that, each and every Azure region is obviously interconnected with each other using what we call the Microsoft backbone, where for now we have close to 200,000 miles of fiber running across the world. And next to that, we also have more than 200 edge sites, or also known as points of presence, which doesn't always reflect a physical location of an actual Azure data center region, but it's still connecting or interconnecting that Microsoft backbone. That comes up quite a lot is, how can we get a view on the Azure data center health state? Because obviously in cloud, you're not managing the data center, you're not managing the physical fabric, and every now and then it might actually be important to know like what's going on. So we provide out of Microsoft, provide a status.azure.com or overall Azure Health dashboard. So out of that Azure Status Health page, you can see a real-time view on all the different Azure regions and geographies, together with a drill down of all the services and a real-time view how healthy that server is. Obviously, ultimately, everything would be green. That means there's no Azure issues, but every now and then you could validate some information about planned maintenance, or maybe there's a warning where something is wrong. And again, it's all real life. Every 2 minutes, it's automatically refreshing the page. Worst case, when you have the idea that some service is not working as it should be, instead of starting to troubleshoot your own environment, I would say start with having a look at your status from here. You can drill down to the Azure Service Health, and that's actually going to bring you into your own Azure subscriptions, your Azure tenant, and specifically sharing information about anything that might impact an outage or some downtime or planned maintenance for your specific workloads. Status page is high level for any customer all over the world, any high level data center view, where the second one, the status health, is a little bit more on your specific tenant, your specific subscriptions. So from here, it's going to show me my detailed subscriptions, so not all Azure subscriptions worldwide, outside of the ones that I can access, obviously, and some details. And again, this is just like a snapshot of what's happening right now during the recording of the session. This could be completely different in 2 hours from now. And that should help you allocating or pinpointing, is that service healthy, is that region healthy? So that's basically the Azure data centers. Next level, Azure Networking. You're in control of your network layer. We give you networking services, but you need to decide on the high availability you need for the service, like business requirements, and based on that, mapping it out. Azure Networking, besides the VNet, the virtual network subnet layer, I'm mainly focusing on load balancing. Why load balancing? Because load balancing as the concept is literally helping you moving up that high availability. As you can see, Azure by itself, even in networking, is not giving you that full 100% SLA, but we're actually pretty close. Azure Load Balancer, the most traditional scenario of load balancing, would give you 99.99 SLA. If you check back in the SLA overview in Azure Docs, or in that slide I showed like 3 steps back, it's literally showing close to 2 point something minutes per month potential downtime. Azure Load Balancer is traditional load balancer running in an Azure region, which can be public facing, internet facing, or using it as an internal one. If you have application gateway as an alternative, it means you're going to typically focus on web applications. Why? Because application gateway can only allow you to publish web application services, but it comes with a lot of cool functionalities that I'll talk about in a minute. Another option is Traffic Manager. It's like Azure Load Balancer, but it's DNS based, and it's also allowing you to have a multi-region high availability. If you got workloads on one end in Azure region, workload in another Azure region, and you want to build this geographical multi-region high availability, you would deploy Traffic Manager. Or across one Azure region, AWS, one Azure region, and on-prem, for example, could also work. And again, ultimately, 99.99 or the industry standard 4.9 SLA, and the same for front door, where front door is pretty close to application gateway functionality with additional security, TLS offloading, rerouting of URLs, redirection, allowing you to integrate web application firewall, and again, giving you that 99.99 industry standard SLA. So important for load balancer, external or internal. So two different scenarios, but you cannot mix and match those ones in the same scenario. So let me switch to another quick demo. If you're not really up to date on what load balancer can do, something new here is like some decision-making tool that you can use to figure out like what kind of topology should I go for, where it's going to ask you a couple of questions. Just know that it's there, it's in preview, pretty cool feature. But if you already have a load balancer, like in my case, I'm actually using it as a front end for an AKS Kubernetes cluster, which means all incoming traffic, internet starting, traffic connecting to the workloads, my services running on my Kubernetes cluster. One example in the architecture would be a load balancer to not only reuse the high availability from your Kubernetes workloads, but also picking up the high availability from that load balancer. Easy said, without the load balancer, there wouldn't be high availability for the workloads, or at least you could not really connect to them in a high availability mode. You would specify your front-end configuration, the backend pool, like my AKS clustered scenario, health probe, quite important for any load balancing scenario where you're gonna rely on the health state, like, hey, backend server, are you still there? If not, I'm not gonna use you anymore. I'm gonna send you to another node. That's literally what a load balancer is doing. The other scenario, application gateway, it's giving you about the same high availability, 99.95, potentially 20 minutes downtime in easy numbers. It's a little bit more than that. But one of the tipping points, I would say, for application gateway is that additional web application firewall. It's a separate Azure service relying on an OWASP open source rule base, but you could also integrate your own custom rule base, and it's going to protect the workloads. Application gateway compared to load balancer is active on layer 7, which means it can recognize the application information in a TCP/IP or HTTPS packet, I should say. The other option in a multi-region scenario would be Traffic Manager or Azure Front Door, where again, Traffic Manager allows you all traffic, no matter what, across different regions or hybrid Azure regions and on-prem or AWS or anywhere else on the planet for that matter. And when something goes wrong, depending on the configuration of the load balancing priorities or properties, it's going to redirect to another region. Front door doing about the same, but it's a lot more intelligent. Again, active on layer 7. It's what I describe application gateway on steroids, because it allows you to run load balancing across multiple regions, and again, some other really cool services. So another demo where I deployed Traffic Manager, and let me start with the basics, where I'm running a couple of web applications, could be web servers as well, not that important. Running down here, 3 different identical web applications presenting a website in 3 different regions. You can see that 2 of them are running and 1 of them is stopped, and that's where my Traffic Manager is going to help me. The starting point is creating Traffic Manager, where you're going to point to an endpoint. An endpoint can be a web app, can be an IP address, public if it's like in a hybrid scenario. And you can also specify the load balancing capability, like the load balancing algorithm. Can be priority based, send all traffic to that specific region. Or let me pull up this configuration list. So you can pick up priority, send all traffic to that one first endpoint with the highest priority, performance based on latency to connect to the endpoint, Weighted would be like a round robin, I think we used to call it before. And geographic is based on your location. If you're connecting from, like in my case, Belgium, and I have a active workload running in West Europe and a US and in APAC, it's always going to send me to Europe. Unless Europe is down, it's going to detect it out of the health state of Traffic Manager and obviously redirecting me. So my priority was defined as US, but since US is down, if all goes fine, it should redirect me to another endpoint. So let's grab this URL and validating where we're going to end up. It's not West Europe because I didn't use the geographical redirection. It's not US because US is down, and it's nicely going to send me to East Asia because it's also the second one in the priority list. So thanks to Traffic Manager, there's no downtime in my application, even if one of the web apps would fail. Cool. Let's move on and sharing a little bit on the virtual machine high availability as well. Virtual machines can be deployed in Azure, Windows, Linux, doesn't matter, in 3 different architectures. Deploying a single virtual machine is going to land somewhere in a physical region like West Europe, Central US, or any of the 64 in a 99.9 SLA mode. That's like close to 1 hour potential downtime per month. Totally fine for demos, totally fine for Q&A testing environments, development environments, although you got dev and test labs as well, and maybe not really recommended for more business critical workloads. What you can do there is deploying an identical virtual machine, but at least 2 instances or more, up to 1000 would be the maximum, in an availability set or an availability zone. What is an availability set? It's where you're going to deploy multiple identical virtual machines across different physical racks, what we call fault domains in the technical terminology, but still in the same Azure region and even more detailed on data center level in the same building. If something goes wrong with a physical rack, you're totally safe. If something goes wrong with a building, you need to move out to an availability zone. Availability zones is, again, starting from at least 2 identical instances, web VMs, database VMs, or any other virtual machine functionality, where this time with a zone, we're going to deploy them still in the same region, but across different buildings, and there's obviously some distance between them. Now you could go like, well, I trust that Azure or public cloud overall to make my virtual machines high available from the start. And again, it's not 100% high available, but I think 4 nines is actually pretty acceptable because it's, again, almost seen as an industry standard for the last couple of years. Now, what could be the reason for moving up that high availability? Because you got 3 possible outages. Unplanned hardware maintenance in the Azure Fabric, the Azure backend, where the Azure layer is going to pause your virtual machine for a short period of time. That's where the SLA comes in. And from there, we're going to move it to another physical Hyper-V server that's waiting to be used and running your virtual machines again. But during that unplanned outage, there is some downtime for the VM. Next to that, you might have literally unexpected downtime, where something goes wrong, but not on the fabric level, but maybe the virtual machine level or the physical host level itself. And obviously you also have planned maintenance where every now and then we also need to patch our fabric, running firmware updates, running server updates, those kind of scenarios. And that's all argumentation for moving your more business critical workloads into availability sets and zones. When you deploy a set or a zone, you need to make some selections. In an availability set, you need to define fault domain, update domains. The fault domain is literally pointing to a physical rack. We're not going to ask you like, these are all the racks in a region, which one do you want to use? But you can choose between 1, 2, or 3 fault domains, which easy said, it's not that easy, but simplifying it a little bit, it means that we're going to stretch your pool of identical servers across different physical racks. And that should give you that pretty interesting SLA. The same for availability zones, where again, your workload is running web servers, database servers, any functionality in the same region like West Europe, but across different physical buildings. Ultimately, you would stretch it out running an active setup where you deploy your workloads in West Europe and identical workloads in East US or any other region for that matter. Just an example, ultimate high availability in each and every region. There's also disaster recovery with Azure Site Recovery, but it's different than high availability, so that's why I'm not talking about it in this session. Besides the runtime virtual machines, there's also storage in the backend. When you create a storage account, so not the managed disks for the newer virtual machines, but overall storage backends, if you want to use file services, file shares, or blob storage, that would be Azure storage accounts. We also provide you high availability options for you to choose from. Local redundant storage gives you 3 copies in a single data center region. Zone redundant, think about availability zones, is going to give you 3 copies in different zones in the same region. And GRS, geo-redundant storage, gives you 3 copies in one region, 3 copies in another region. One of the newer ones, I would say, is ZRS, geo-zone redundant, where we're going to store zone redundant in the primary and local redundant in a different geography. And you could also have the RAGRS, RAGZRS, pretty complex for me to express, but it's a read access. So you have your prime region and replicating, cloning all the changes from the storage account level to another region, and we're going to store it for you in a read-only format. That would be the scenario. And yes, another demo coming up. If you want to deploy a new virtual machine and you want to make it more high available from the start, you would allocate the availability options down here. Now keep in mind, although I would actually recommend everyone to at least deploy any workloads in a set, ultimately in a zone, that availability zones are not available in all 64 regions. From here, you select the zone or the set. Scale set is grayed out here, but what it allows you to do is running an automatic scale or manual scale. Like whenever needed, I want to add multiple servers, where the default used to be that the scale set was automatically an availability set as well. But again, it's not available. Zones, at least, are not available in all regions. And at least 2 instances or more, deploying 1 VM in a set would not really give you better availability. Moving over to an availability zone with 1 single VM obviously is not really going to help you. So a couple of best practices and closing the virtual machine high availability topic. Configure at least 2 VMs or more, up to 1000 in a set or a zone. Use managed disks is going to give you better high availability from the storage perspective. Use scheduled events to maybe optimize the maintenance for the VMs that you can control. And also important, deploy each and every application tier in a set or a zone and not mixing workloads. What it means is that if you have like a 2-tier application, web applications, all web VMs will be deployed in one availability set. All the database servers will be deployed in a different availability set or a zone, and not mixing one web VM with one database VM in the same set. That's not going to help you. And ultimately, again, combination of zones and sets, and maybe if you want some standalone VMs, but they're not coming with a great SLA, I would say. Moving on in the stack, we're a little bit over halfway through. I hope you still learned from it, you still enjoyed the session, and moving to platform services. Where Azure App Services are not all equal, mainly looking at it from, again, an SLA perspective, where if you deploy app services, it gives you overall app services, functions, logic apps, mobile apps, and API apps. Logic apps provide you an out-of-the-box SLA of 99.9. If you deploy app services or Azure functions, out of the box it's coming with a 99.95, and we don't have a 4.9 SLA for app services. So what would be the workaround? First of all, something totally new since only last week, you can now deploy app services in a zoning concept. Everything you picked up in availability zones for VMs is now also valid for app services. And I should actually update my slide where now we have that 4.9s, that's the zone concept, but only since September. And for now, not available from the portal deployment, but only through ARM and Bicep templates. Another scenario that actually helps you in high availability is obviously deploying more web apps. So you could have a dev and test environment, staging environment, production environment. You deploy the production website. If something goes wrong, you're gonna fall back to the staging environment, redeploying it, maybe DevOpsing it in whatever pipeline scenario you could think of. Running a new deployment in a manual way would also still work, and technically it's actually totally fine. However, within App Services, we can now deploy an app deployment slot environment. I like to describe it, although technically it's not really built for an high availability or disaster recovery scenario, but it's one of my favorite scenarios that I like to describe as the oops admin. Imagine you deploy a new version of a web app receiving from your developers. You're gonna push it out to production, but you forgot to test it in a dev and test or staging environment, which means your production environment is now a little bit messed up. The web app is not working anymore, or maybe it's not working as it should be, or anything else not that important. We're now, instead of going back to the previous design and relying on staging, dev and test, redeploying everything, we could now rely on a swap of a deployment slot, which means instead of running backup restore, running new deployments, we literally push our deployment slot button and it's going to fail over from one to the other. And yes, I got another demo on that. So I deployed my web app environment, a different one that I used for my traffic manager demo, where the traditional scenario would be something like this: 2 standalone web app environments, one for Canary like dev and test staging and another one for production. Or what I'm using is .NET 3 point something, in which I created my deployment slots. So it's a characteristic, a capability of an Azure App Service, where you dive in, you initially deploy your original plan, I would say, and from there you're going to create an additional deployment slot, one single one or multiple ones. It's not that important. You can actually add multiple ones depending on the app service plan. That's where the cost and features are actually coming from. So I have my base app service environment defined as the production environment, and I got a second copy as deployment slot, staging, production 2, or any other version naming convention you want to use. So let me open up a second browser window where, at least for the first one, my production environment, if you want, I'm running version 0.3 of my web application. Super basic web app. This is web app version 0.3. Imagine that there's something wrong with the web app. It's not running as it should be. It's lacking some features. There's some issues in what my developers provided me. Even out of DevOps pipelines or anything else, it's not going to fix your problem, right? So what we can do here is going back to that deployment slot. I'm going to do the same here. Let me go back. It seems to be a little bit faster. Well, now I got my second environment running, but it's closer to the production environment than having 3 different web environments running. Where now, if something goes wrong, instead of again running that backup restore operation, running a redeploy, going back to the developers, running Git source control integration, and maybe running a previous version of the commit, I could now perform a swap. Now what's going to happen here, and it's a little bit throttled on my environment. In real life subscriptions, it actually goes a lot faster. I'm going to trigger a swap, and what's going to happen here, the base URL remains the same. So we're not shifting environments, but we're shifting content. And if all goes fine, it should go back to the previous state of my workload. This could also be browser caching. So I'm going to try and speed it up a little bit. It's probably still swapping it out. Typically it takes about 20-30 seconds, but on my environment it's usually taking a little bit longer. But eventually, as you can see, I'm still in the production URL, but it is nicely showing me the old version of the website. 2 more topics to go, one for data solutions and one for serverless. Data solutions, I cannot really cover everything, keeping the limited time in control, but the good news is that almost any Azure database as a service gives you pretty high SLAs. Azure SQL, like running SQL Server instead of a virtual machine architecture, moving to platform as a service, gives you the 4 nines. MySQL, PostGress, MariaDB, I think, but I'm not 100% sure, also giving you that close to 100% SLA. And ultimately, Cosmos Database, one of our newer database scenarios, although it's been around for like 2 years or 3 years maybe, is even providing a better SLA than the other more traditional relational database flavors. I'm not going to bore you with SQL Server. I assume that you already know SQL Server, where it's giving you 0 downtime. Why? Because in the back of the platform, we're going to build a high available SQL Server database instance for you. You point to your database instance. You can play with failover groups and everything across multiple regions. That would be the idea. And from there, the other scenario with more open source databases, as we call it, Cosmos DB, MariaDB, Postgres, or even within Cosmos DB, you have Mongo database, Cassandra, you got Graph, API based on Gremlin. And if you are using storage account table as an option, you could also migrate into Cosmos DB with the table API. What makes Cosmos DB really, really awesome is the built-in high availability coming out of the box. Next to that, super fast, low latency across different regions. The only watch out is your consistency level. So feel free to check in some Cosmos DB specifics later on if you want to find out how it's technically working. In short, for the SQL scenarios here, MySQL, Postgres, but technically it's about the same for all the other services. You have your application, you use a connection string, and in the back, we're going to give you some invisible gateway. The gateway is connecting to your database instance, where you're going to deploy multiple instances and eventually running in some Azure storage backend. That's hosting your database, right? You're going to deploy a second instance. Out of the SLA, we already provide one for you, but if you want, you could also tune that and adding more database instances. From there, when something goes wrong, you don't have to do anything. You don't have to run a failover process. It's all happening for you because that gateway intelligence is taking care of that. About the same for Cosmos, what I already mentioned, highest SLA in the platform, low latency, all database operations will be complete within less than 10 milliseconds. And you could also move to multi-region replication. And on top of that, multi-region read-write. And again, consistency level would be quite important. How do you define that? You can choose from the beginning when you create your Cosmos DB instance. We're going to ask you a couple of questions. Obviously, if you deploy that from the portal, if you already have Cosmos DB up and running, it's also allowing you to modify those changes. You start with a small database, standalone, one single copy, already 5 nines high availability. And if you want to max it out, you could even do that by going back into your configuration, diving into the database settings, where you're going to specify the replication topology and the consistency levels. And even there, if you have no idea where the different Azure regions are located, we're actually presenting you a nice global view map, and you just need to pinpoint, like I want to expand, synchronize my Cosmos DB instance from West Europe to somewhere central US, confirming the changes, and it starts replicating, and that's basically it. So really, really easy, transparent for you to configure. Last service for now, we're almost there, is Azure Serverless. I don't have the capability to list up all the Azure Serverless components. It's growing by the week if you want. But if you think about serverless, it's Azure Functions, Event Grid, bot services, IoT hubs, event hubs, service bus-alike scenarios, where each and one of them are coming with an OK SLA. And obviously, one architectural design would be adding multiple services to make it more high available. Talking about architectural designs, 2 last pieces of information I want to share. You got the Azure Architect Center, or Reference Architect Center as we typically call it, where you're going to find more than 100 architectures for different Azure services for case scenarios. If you got a finance organization with finance application workload or e-commerce or streaming data or anything, have a look at the reference architecture. If you already have your Azure environment up and running, you could also have a look at another super valuable source of information called the Well-Architected Framework. What the Well-Architected Framework allows you to do is running an assessment on your existing environment for reliability, that's why I like to talk about it, but also covering security, cost optimization, overall operational excellence, and performance tuning. Let me close off with one last demo where I got my well-architected framework already up and running. You just go to the Bing or you search for it in whatever search engine. It's integrated in the docs, but it's not a static file. You could start with architected framework up here, preparing the assessment. I already partly started one. You can choose what kind of assessment you want to go through. Sorry. Pointing out reliability, it's going to walk you through a pretty interesting set of questions where for each and every question, it's going to show you some details to go through. And based on that, it's going to present you like you are pretty well reliable, or there's quite a lot of room for optimization and so much more. Next to that, go back to that Azure Architect reference center for more technical details, descriptions of everything that's already deployed in your environment and maybe figuring it out. Another integration is Azure Advisor, and it might be called Advisor in the meantime. There we go. Where it's going to show you about the same, giving you recommendations based on high availability, reliability, cost optimization, security is another one. Bottom line message, a lot of tools available that's going to help you in optimizing the high availability of your environment. And with that, we're close to the end of my presentation. First of all, again, I hope you enjoyed it. I hope you learned from it. I covered high-level SLA concepts, Azure data centers, networking, moved over to virtual machines, app services, a little bit on data, SQL, Cosmos, and closing with serverless. If you got any questions after watching this session, feel free to reach out or stay in touch. petender@microsoft.com. Find me on Twitter. Maybe follow me on my blog every now and then with some interesting blog updates on typically the Azure platform. So with that, I'm going to once more thank you for being here. Thank you for watching my session. Thank you once more, Dwayne, for organizing the Azure Back to School. I hope you enjoyed the rest of the month with more technical Azure details, and hopefully seeing you all again next year with another interesting topic on Azure. Enjoy your days, your evenings, your nights, any timing you're watching these sessions, and take care of yourself. See you soon.